wanted to do C because I can, I guess. I don't know. I made a choice. So we have two fractions equals to a number, which is all well and good. It is a little bit different than what we had in the bell work, because in the bell work I just had like without the 3 part, without this equals 3. So the bell work was a problem that looks like this, where we were simplifying. This time we have more. We have the equal sign. So since we have that equal sign, we don't necessarily need to get to common denominators to be able to add that together. What we're going to do is we're going to find our least common denominator to multiply everybody by, so to get rid of all of our denominators. That would be ideal. So on this guy, I have a chunk in the denominator here that's an x plus 1, and I have a chunk in the denominator here that's an x minus 3. What is the denominator on 3? 1. I could put this as 3 over 1. So our least common denominator here, I'm just doing so 5, is going to be what pieces? Our x plus 1, that's a piece that's in the denominator, and our x minus 3. Are we good? Yeah, I'm thrilled that we're so giggly about this test we have tomorrow. Yeah. So when we find that least common denominator, the benefit of that is we can come here and get rid of all the fractions. I can take my 3x over x plus 1 and multiply that by our least common denominator, that x plus 1, x minus 3. And we can take our fraction that has our 2 over x minus 3 times our least common denominator of x plus 1, x minus 3. And that's set equal currently to our 3 times our least common denominator, that x plus 1, x minus 3. The benefit of writing it out like this is we can see the pieces that cancel out fairly easily, because we have over here our x plus 1 that cancels out. I have over here my x minus 3 that cancels out. So we get pieces that leave, which are going to leave us with our 3x times x minus 3 and our 2 times the x plus 1. That's equal to our 3 that's times both. And I am going to multiply that out. I'm going to close the door first for us. So we're going to multiply that out. We do need to multiply both sets of these out so that we can try and solve it. We're trying to get all the way down to an x equals. So we're going to need to multiply that out. So multiplying out my x minus 3 times my x plus 1. Just because we're going to take a couple of rounds on multiplying here. So we're going to have our x times x giving x squared, x times minus 3 giving minus 3x, 1 times x giving a positive 1x, 1 times minus 3 gives us minus 3. So I'm just multiplying those bits out as we come across them. There are lots of different orders in which you can do these several steps. But when we do this, and when I start multiplying out on the left-hand side as well, we're going to have our 3x times x giving us 3x squared. 3x times minus 3 gives us minus 9x. Then we have our 2 times x giving us a plus 2x. 2 times 1 giving us 2. And then we're going to have on the right-hand side, we can combine our like terms together, minus 3x and plus 1 to get a minus 2x. And we can multiply this out to get 3x squared minus 6x minus 9. So I did a whole bunch of steps in there all at the same time. So if you are not entirely sure what I just did, please let me know, because we just did a whole bunch of steps all at once. I'm just lowering these down.
That's negative 6x.
That came from my 3 times, when these two guys combined together, it was our minus 2. So I'm really multiplying the 3 times the minus 2 here, because these two pieces combined together to make that. If you do it as 3 times minus 3x and 3 times 1x and then combine together, you should still get your minus 6. But then we have like terms, and I can do some combining together again. We've got our 3x squared minus 9x plus 2 gives us a minus 7x plus 2. What can I do now? I have a lot of stuff here, but I've combined all my like terms. What's our next step going to need to be? Trying to solve that, trying to get to an x equals. You can subtract 2 on both sides. How's that helping? What are we trying to do?
I'm trying to get one of these sides equal to 0.
Trying to get a side equal to 0. So let's go with maybe moving our 3x squared from this side. Minus 3x squared minus 3x squared. Hey, wait a second. When I subtract 3x squared from here, that cancels out. And when I subtract 3x squared from there, it cancels out. We like that. So then let's move something else. Maybe we add our 7x. That gives us 2 equals negative 6x plus 7x gives us just 1x minus 9. What should we do here? Add 9. Add 9 to both sides. Once those x squareds canceled out, we don't need to aim for 0 anymore. We're just trying to get x by itself. So we get that x equals 11. So there's a whole lot of stuff going on, but a whole lot of it winds up canceling out in this row. So we subtracted 3x from both sides, and we get left with our minus 7x plus 2 equals minus 6x minus 9. If I add my 7x and then add my 9, we get exactly all the way to our answer. Our last step on these is to check them. We do have to check them. And when I say check, what that means is I say, if x is 11, is my denominator 0? So if this is 11, 11 plus 1, definitely not 0. If this is 11, 11 minus 3, also not 0. So this does check. If it equaled 0, that's when we would have an extraneous solution. So you have to check it to make sure that it is a valid answer. So this is very, very close to what the bell work was in look, but it's a very different approach than what we did in the bell work, because we do not need to get to a common denominator to add them. We can just multiply everybody by that LCD, least common denominator. Questions on that one? Okay. What other questions would you like to work through on this review? Get through it. See what you want to do.
Number 4.
Number 4. Okay. Number 4. We've got working alone. It takes Jamie 40 minutes to clean the kitchen. And her brother James can clean the kitchen in 25 minutes. So we want to know if they teamed up, how long would it take them to work on to clean this kitchen? So if it takes Jamie 40 minutes and James 25 minutes. What are we going to do for Jamie? How are we going to write this out? Yeah, Jamie's going to do the one kitchen per 40 minutes. And then we'll have James here. And we can put it together very, very similarly. He cleans one kitchen in the 25 minutes. So if we want to know what it's going to take if they work together, if they combine forces, what do? How do I figure that out? We will. How do I finish building this though? 1 over x. And we need to add these guys together. So we're looking at our 1 over 40 plus our 1 over 25 equals 1 over x. And then, Sean, you're exactly right. We're going to look for that lowest common denominator, or looking for a common denominator that we can use to help us solve this. What are we going to use for a common denominator? Say it again. 5 would be a common factor. So 40 and 25 are both divisible by 5, but that's not what we're going to need to multiply. We want to be able to get rid of all of our denominators. Say it again. 40, 25, and x is a totally valid way to do this. It's not the lowest common denominator, but it is a common denominator, and it'll totally work. So if I multiply everybody times 40 times 25 times x, you totally can. Times 40 times 25 times x times 40 times 25 times x. The benefit of doing it just like that is it makes it really easy to spot how things are going to cancel out. The 40s are going to cancel out here, leaving us with 25x. Our 25s are going to cancel out here, leaving us with a 40x. And our x's are going to cancel out, leaving us with 40 times 25. And 40 times 25 is 1,000. Now 40 times 25 times x is not the lowest common denominator. That would be a 200x, which would also totally work. That would be the smallest number that's divisible by both 25 and 40. But this totally will work. What can I do next to solve this? Combine our like terms. We get our 65x equals 1,000. What do we get? What's our x going to be? Yeah, 15.38 minutes. So it would save them both time to work together. More than half for Jamie and almost half for James. So for them to work together, it would be 15.38 minutes. Do not tell me that's 15 minutes and 38 seconds. Just tell me 15.38 minutes. It is not 15 minutes and 38 seconds. 15.38 minutes. What else do you guys want to do? We got 20 more minutes. We got time to do a couple more if you want to. Or if you just want time to work, that's okay too. Someone have another one you want to do?
8 and 9.
8 or 9? Let's look at 8 and 9. Not doing both. Pshaw. Let's do 8.
Yeah, I was looking over the white for KX.
So that would be if we had KXZ, that would be if we had something varying jointly. So the direct variation is going to be this guy. The joint variation is this. So this is direct. This one is inverse. And if you have something that says jointly varied, this is our joint variation. Because it's a few things joined together. What's up? Hang on, Sean, hold your, what's up, Ashley? For the chapter test, don't think so. Oh, yep, it does have the formulas we need. It'll have this one, and our transformation form are on the front of the test. Yeah, this formula, and the transformation form, so our a over x minus h plus k, are on the front of the test.
Arby, is any of the KXZs that have been on the test or no? Can you confirm that?
These two formulas will be on the test.
So no.
These two formulas will be on the chapter test.
Unless you're gonna do what you did last time, we won't put all of them down. Just gonna actually memorize some of them.
These two are on. They're on the test.
I'm ready for 8. Wow.
So when we're looking at these kinds of things, remember we're looking at things that vary, and they're giving us a word right here. So this one is going to vary directly, which means we use their two pieces that are directly opposite the equal sign from each other. Direct means is like there's not going to be a whole lot different on it. That's our y equals something times our x. And they give us an example here. We know y is going to be 9 if x is negative 3. So you can set it up like this. If you notice that it does actually have that x varies directly, so it's got them swapped technically in the sentence, you can still absolutely do this and get to the exact same answer. Your k is just going to be different than mine. So if you set it up this way, trying to figure out what our k is, we're dividing by negative 3. So 9 divided by negative 3 is negative 3. So setting it up this way, our y equals negative 3 times x. So if we want to find x when y is 12, we substitute that piece in. I know my y is 12, and we have negative 3 times x. So what is our x going to be? Yeah, we divide both sides by that negative 3 so that cancels out, and we're left with a negative 4 equals our x. What is with the color changing randomly? So whether you set it up this way, or if you notice that the x's and y's got swapped and you set it up as x equals k times y, that will also get you to the exact same answer. You would just have a k of negative 1/3 instead of a k of negative 3. So it'll do the exact same thing. They're inverse relationships, or so they work the same way. They're very, very similar. So you're going to work with the formulas we have. Our direct is directly across. Our inverse is the one that has the fraction. And we can go from there.
Okay, for the name the asymptotes, or it's called.
At the top of that page, number 7.
No, I'm talking about just like anyone that says name it. Horizontal is the H value, and vertical is K, right?
So the way I remember it with the vertical and horizontal asymptote, our vertical V kind of sits in the nest of the X. X is always going to equal H. Every single time. The horizontal asymptote is always going to be our Y equals K. X, just like we do with our transformations, X plus H in the transformation table. Y goes with K, YA plus K, graphing makes us yak. YAK. Y and K are a team. They stick together. X and H are a team. They stick together. So the vertical asymptotes are always going to be our X equals. Our horizontal asymptotes are going to be the Y equals. I mean, if you think about our Y, if I was to, I don't know if it'll let me, take my Y and flip it, it kind of looks like an upside down H. So that's another way to kind of think of it. If you do a loopy H like I do, it can flip. I'm trying to, it's not like letting me show you in person. So Y switches to our horizontal asymptote, not the letter H, but that's our horizontal asymptote. So whatever works for you to remember that. I like to do the V sits inside the X very, very well, sits nicely, because I draw my X as angular and my Y is loopy-doopy. X goes with H, just like in the table. We got 10 more minutes-ish.
So, this would be the answer for number 1A.
1A, you gotta get yourself into your transformation form. Not off the top of my head, hang on. Yep. That's your -4 is which piece?
So I wouldn't have it, right? I just had to.
Is it A, H, or K, that -4?
That's K.
Mm-hmm. Yeah.
This was a vertical.
X goes with H, X is the vertical. Y goes with K, it's your horizontal.
At first I put it, I had it right at the first time. Which how you
Then have faith in yourself.
How do you explain it? It seems like I was swapped.
Have faith in yourself. A vertical one always goes with X. This is always going to be our X equals H.
That was my question earlier.
Easter. You said 9. Looking, I think 9. That's not what I have, but that doesn't mean a dang on thing. Give me a second. Let me see. Let's switch up their way. Let me see what you did. Because new. I said no, but let me see what you did. Okay. You comboed. If you're gonna do it yx equals k, set it up like that. If you're gonna do it fractiony, like the little formula guys over here, make sure you get your y and k in the same spot, because you did not k over x, you did y over x. You did y over x, so you can either do y times x equals k, totally valid. Y over x equals k, that's actually this. Okay, you set it up as a direct. So be super careful. Do you guys want to have these last 10 minutes to work on stuff? Ask questions if you got them? So I'm just getting very specific questions right now. Okay. Then I'm gonna cover that. Nope, not that page. 1, 2, 3, There we go. There we go. Work on stuff. Chapter test is tomorrow.